Hey everyone. So after spending some time, I figured out where we went wrong and where where I went wrong. So looks like the way I was implementing it was wrong, but I have figured it out where I was going wrong. But in order to fully grasp the depth of this, what we'll do is we'll go over we'll go over the brute force approach on how it is working. Okay, so we'll take a simple example of 1, 2, 3. Okay, so this screen. Okay, yeah. 1, 2, 3, and the amount would be 6. Okay, so basically, what's happening is that we have to recurse on all of these guys, right? And we can take n number of coins to achieve this amount. Okay, so what we are basically doing is taking n number of coins and going about to see if we reach that element or not, sorry, amount or not. In that process, so let's see what we are doing here exactly. We um, we send the amount, and we so there are basically two checks that we have to do. If if amount will be basically reducing this amount, adding this coin. If we add this coin to 6, then it will be 5. Then if we add it again, and so on and so forth. So we'll be adding such amounts, adding the sorry, subtracting the coins from the amount that we have. If amount reaches 0, then we know that we have found our uh, found the found, found the number of uh, found the coin, which when subtracted from the number leads to this amount 0. So we send 0 back, and if amount becomes less than 0, then we know that we cannot reach this amount. So we basically send infinity, because if infinity is there, then we cannot reach that amount, right? Even if we add n number of coins, we'll be not able to reach that amount. For example, if our coin is 5 and we are told to reach 2, so it already makes sense that even if we add any amount of 5, we cannot reach 2. So that's infinity, and in that case we have to return -1. If uh, our answer is infinity, then we have to return -1. So what we have to do is we have to basically traverse all of this. So first of all, we'll take go in it is a backtracking kind of solution. So we'll take 1, and what we can do here is we can keep either take 1 or take its neighboring, but as the recursion goes, we'll keep on going with 1. So if we take 1 at this point of time, our 6 will become 5, and then we take another 1, our 6 becomes, so this is, let me just minimize this so that, yeah, you guys can see this. Okay, so yeah, no, I keep here 1, then this becomes 6, oh sorry, 4, then okay, let's keep on adding 1 until 0 is reached. So 1, so here it will be 3. I won't change the color, it's taking too much of time. So 2, and then okay, and once we add 1, another 1, then this is 1, and then once we add another 1, then it will be 0. So how many 1? 1, 2, 3, 4, 5, 6. We added 6 ones, right? So that's what we did. So we reached to 0 here, if you are able to see this. Yep, we reach to 0, and what we do from this point a point is that we start returning 0, 0 to the previous element, and we we always keep minimum as infinity. So we check if the current returned is infinity, or it is if it is not an infinity, then we what we do is we add 1 to it and store it as a minimum. So our minimum at this level, let's keep it as green, 1. But what at every step what we are doing is we are traversing its other coins also. So at this stage what we do is we'll traverse other coins, which will be 2, and once we subtract 2, and at this stage our total was 1. Sorry, we won't be doing that here, but we'll be doing that here, right? Because we have returned it from this guy, and so we added a 1. So looks like, so 1, I subtracted it and sent it 5, then I sent 0. So yeah, sent 1, subtracted it, then it will send 0 to this guy, right? And if we see our problem, then 0 is returned back to this guy, and we find out the minimum. Okay, so yeah, basically we will be sending if we take 2 from here, then 2 minus 1 would be minus, so infinity would be sent, but we don't do anything for infinity. And similarly for 3 would be sent, we don't do anything with that as well. So here we'll be sending back 1. 1 will be sent back here at this stage, and then we'll check for 2, and 2 minus, so we'll be checking with this guy, right? Because we have 2 at this stage, so 2 minus 2 is 0. 2 minus 2 is 0, so we can Okay, at this stage, so 2 is 0, then returned, then we return a 1. So this guy has
Now we
1.
are having, let's say, three
Sorry.
number of coins 1, 2 and 5, and our amount to be found will be
Okay, guys,
6.
sorry.
Now
Wait.
I am taking the columns to be equals to amount.
Please.
Okay, so this DP table will be of size number of coins plus 1, that is n plus 1, and amount plus 1, that is m plus 1. And we are taking one extra.
Hey, sorry guys. I had a call in between. So what happens when we send to okay, let's see the editorial, and maybe we can have a better understanding of how it is getting done. So we came till this point and then we add 2. So we were right till this point of time. Okay. So I add 2 coin 2, it becomes 0. But then I should be sending back 1, right? And how will this be getting updated? I'm just wondering that. So my answer, so minimum at this stage will be 1, and this also will be 1, right? Okay, I think I should do it properly rather than, let's rub this out. Okay, so let's go about this. So our coin is 6 here, right? Let's use white itself. So if I give it coin 1, then it becomes 5. Then I give it coin 1 again, then it becomes 4. If I give it coin 1, becomes 3. I give it coin 1, it becomes 2. Then I give it coin 1 again, it becomes 1. Then I give it coin 1, it becomes 0. So as soon as it becomes 0, I'm sending it back to this guy, to this guy, and at this level I am setting minimum to be 1. Then I traverse, then as the remainder is 1, we give it coin 2, it becomes minus, goes in minus. As we give it 3, it goes in minus. So this is, so for our understanding purposes, we'll draw it in 2, 3, minus, minus. Okay, not to create confusion. So we'll be returning, sorry, my bad, I should have changed the color. We'll be returning 1 to this guy, right, where we had 2. Then what we do is, for 2 we subtract 2, and we immediately get 0. So at this stage we send back 0, we add, so here the minimum is set to 1, and this guy also sends 1. So minimum, so here it would be 2. So once we send 1 from here, 0 from here, 0 is sent back, then it adds 1 to it, 0 is sent back, sorry, here 0 is sent back, and here 1 is added to it, so 1 is added to it, and then 1 is sent back. And at this stage 1 is added to it. Suppose, yeah, this will work first, right? So so the minimum would be 2 at this stage, and this guy sends back 0. So what should be the answer? So 1 plus, so minimum would be 2 and then 1, so that should give us, or can we, can So this guy 2, since its at minimum would be 1 at this stage, and then answer coming from 2 would be 0. Then we find minimum 1 plus ans would be, minimum was 2, right? Yeah, so sorry, minimum was 2. So okay, let's do one thing. So when 0 is returned back, what we do is we add 1 plus 0 and then we send it upper to the uppercase upper call. Then it receives 1, it add 1 to it, and then minimum changes to 2. Then 2 sends 0. This was for 1, and 2 sends back 0. Then 1 plus 0, then minimum is set to 1. Then this guy changes to 1 because 2 sends 0, and then this guy is sent forward to 3. Then at this stage um, here it is 2 because we sent 1 and 1 plus 1 is again 2, so minimum is 2. So we add coin 2 to 3, this will give 1, and then again we can add 1 to it, then it will become 0. Then again we are sending in, and as you can see this is repetitive work. So amount here was 1, then we did this, so we can store this in the cache so that it directly returns 0 to us. So at this stage we can reduce the repetitive work and then directly send the amount to the 3. Yeah, it's pretty convoluted if you are doing it with hand, but once you get the idea of it, like how it's going to work, um, it's pretty intuitive, but not that intuitive. I don't know at this point what I'm saying, but it's, if you get it, you get it. Yeah, I would just stop saying anything after that. Okay. So, so here what they are showing is 2, at 2 we get this, then we update minimum, then here we added 2, C1 0, and then 3 0, then we update this, and then we probably might have sent 1 again above, and here we do the same thing. So here the same repetition what happened here, we can see that here, sorry, this guy. Yeah, so yeah, we can just return the repetitive work and then send back. So what would be sent back from here? Here we might be sending 1, then okay, as you can see there is a lot of repetitive work going on, and using cache is the way to go. So yeah, this whatever total that we count at the end, like for the total whatever the minimum that we have encountered, we store that, and if such total appears again, we simply return this with the help of cache. So time complexity time complexity of such algorithm might be n raised to amount. N raised to amount is until that amount is reached, we'll be doing that. But if we use cache, um, then does it become n of n, the time complexity, because we won't be doing the repetitive work again and again, or n into amount. No, what am I saying at this point? So if in case we are using, yeah, n into amount memoization, that's what he okay, yeah, that's what he did. uh, okay guys, in hopefully, like, I know it did not make much sense, and um, but the thing is, like, this understanding this, like, we have to take the whole amount and then start recursing it using this for loop was important. And um, basically this, and how we are maintaining the minimum and sending the minimum, so that part was important. This is pretty interesting problem. I'll add this to my favorite list. Did I add, oh, this problem to my favorite list, and then graph? Cool. Next, I need to see what's going on with this. It's already like an hour above that I'm trying to understand what's going on in this problem. Okay, cool. See you in the next video.